This is a review of solving equations algebraically. So in number 1, you have negative 3x minus 2 equals 7. First, you want to rewrite subtraction as addition. So you're going to rewrite the equation as negative 3x plus negative 2 is equal to positive 7. Then the first step you want to take is you want to add positive 2 to both sides. So since you have negative 2, you want to add positive 2 to the left side and the right side of your equation. So that means that negative 2 and positive 2 are going to cancel out to 0. So you're going to be left with negative 3x plus 0 equals, then 7 plus 2 would give us 9. So negative 3x plus 0 is negative 3x equals positive 9. Now to solve for x, you divide both sides by the number in front of x, which is negative 3. So divide both sides by negative 3. Then that means the negative 3's cancel out on the left, and you're left with x equals 9 divided by negative 3 is negative 3. So x equals negative 3. Now to check, you rewrite the original problem. So I'm going to rewrite it as negative 3x plus negative 2 equals 7. And now you want to replace x with your answer, which was negative 3. So you have negative 3 times the value of x, which is negative 3, plus negative 2 is going to equal positive 7. So negative 3 times negative 3 is positive 9. 9 plus negative 2 equals positive 7. 9 plus negative 2 is 7. So that means since 7 equals 7, that means we solve correctly. In number 2, you have x divided by 3 plus 4 equals negative 2. Since this is already addition, you don't have to rewrite the equation. So all we have to do is get rid of 4 by adding negative 4 to both sides. So negative 4 and positive 4 are going to cancel out. So you're left with x divided by 3 plus 0 equals negative 2 plus negative 4 would be negative 6. So x divided by 3 plus 0 is just x divided by 3 equals negative 6. Now when you have a number underneath the variable, you multiply both sides by that number. So I'm going to multiply both sides by 3. So on the left side, the 3's cancel out, and you're left with x is equal to negative 6 times 3. So you multiply on the right side, and you get negative 18. So x equals negative 18 would be our answer. Now to check, you rewrite the original problem. X divided by 3 plus 4 equals negative 2. And you want to replace x with negative 18. So negative 18 divided by 3 plus 4 equals negative 2. So now divide negative 18 by 3, and that would be negative 6 plus 4, and we're going to verify that that sum equals negative 2. Negative 6 plus 4 is negative 2. So if negative 2 equals negative 2, that means we did solve correctly. Number 3, you have negative 3 times the quantity x minus 3 equals positive 6. So because we have subtraction, you want to rewrite the equation as negative 3 times the quantity x plus negative 3 equals positive 6. So multiply negative 3 times everything inside the parentheses. That's using the distributive property. So negative 3 times x would be negative 3x. Negative 3 times negative 3 is positive 9. That equals 6. Now we're ready to solve, so add negative 9 to both sides of the equation. So negative 9 and positive 9 on the left side will cancel, so you're left with negative 3x plus 0 equals 6 plus negative 9 would be negative 3. So negative 3x equals negative 3. Now divide both sides by the number in front of x, which is negative 3. Negative 3 and negative 3 will cancel out, so you're left with x equals, on the right side, negative 3 divided by negative 3 is positive 1. So x equals positive 1. Now to check, copy the original problem. I'm going to rewrite the one that has addition in it. So negative 3 times the quantity x plus negative 3 equals positive 6. Replace x with positive 1. So negative 3 times the quantity 1 plus negative 3 equals 6. You can use order of operations and add 1 plus negative 3. That's negative 2. So then you have negative 3 times negative 2, and we're verifying that that equals positive 6. Negative 3 times negative 2 would be positive 6 equals 6. So that means we solved correctly. So this concludes our review of solving equations algebraically and checking.